Hope you've been having a nice weekend at the Maker Faire, wrapping up today. So near the end of our day here, we're doing our Getting Started with 3D Printing talk. I hope you've had a chance to look at the 3D Printer Village, but if you haven't, you've got a little bit of time after this talk finishes to check it out. We're going to be talking about 3D printing and what it's all about, and we'll do sort of a 15 to 20 minute presentation, and then I'll answer any questions that you have. So first off, what is 3D printing? 3D printing is sort of a colloquial term for additive manufacturing. And additive manufacturing describes any process that is essentially controlled by a computer and built up in layers. And that can be done in lots of different materials. Most of the 3D printers that you're going to see out in 3D Printer Village are going to be this type here. If I can get that video to run. Maybe not, I'm on a different computer than I was yesterday. So if you go over to 3D Printer Village, you'll see a lot of these types of printers called fused filament fabrication, and they're taking essentially a spool of plastic, which is a sort of a string of plastic that goes through a nozzle, is computer controlled, and lays down a design sort of in layers, like a very precise computer controlled glue gun. And other processes, like the Form 1s and the B9s, cure resin in layers, either through a projector or with a laser beam. But this is really only the start of the types of additive processes that are out there, and we'll get to those in a little bit. So what can you use 3D printing for? Design, art, any ideas that you've got out here. These are some examples of designs that are on Thingiverse, some fine art, some gaming miniatures, some play sets for kids. You can prototype your ideas, whether you have an idea for an invention or just something that's going to solve a simple problem in your life. Maybe it's an enclosure for an electronics project. One of the things there is, I think, a model of an automatic transmission. You know, it's a great tool to show people how things work, whether it's an engine or there's also a model of a planetary gear set there, to get these concepts sort of in reality and be able to show your friends and your family and your kids. What else can you use it for? We can invent new things, share our dreams, and also share our dreams with other people. One of the interesting things about 3D manufacturing is that it sort of ties into this idea of distributed manufacturing. That I can make something, I can share it online, and you can make that thing. And that's one of the, when I got my first 3D printer, I started sharing my designs online, and it was really awesome to put something online one evening and then wake up in the morning and have someone that printed it out and posted it that lived in Japan. And that's a crazy feeling that your designs exist sort of all over the world. And you can use it to sort of explore and capture your world. You don't have to be a pro modeler to use a 3D printer. There's some really great software out there that allows you to scan items out in the real world, either with a camera or with a Kinect sensor or a high-end system. But you don't need to spend the money on those high-end systems if you just sort of want to get your feet wet and get started. People are also doing some really awesome things with 3D printers, like creating prosthetics for kids. Kids grow so fast that often they don't get a real fully functional prosthetic until they're at least in their teens, and they miss out on a lot of activities. And so there have been a couple of different projects of folks who've been prototyping designs to give kids who don't have fingers be able to catch a ball. And if you're using low-cost materials like the ABS or the PLA that the FFF printers do, you can make one a year, and it's not that big of a deal, especially when the design is open source and anybody can contribute to it and it's free. So we started talking a little bit about what's available today, these two different models. The fused filament fabrication, that's the ones that are printing out plastic that looks a lot like Legos, or the stereolithography, which is often clear, but can be lots of colors and has a higher resolution. These are the two kinds of processes that you can buy and have at home. But in a few years, there's going to be a few key patents that are expiring. And so we'll see some of the other technologies that you can only access through the high-end systems or a service bureau like Shapeways available in the home. Selective laser sintering is one of them, and we're already seeing some of these printers come out of China where these patents aren't protected. And when those patents expire in about the next year and a half, we're going to see some of those new technologies available to regular people like you and me. But you don't have to have a 3D printer to have a 3D print. There's also these services like Shapeways, Sculpteo, iMaterialize, where you can create a design on your computer, you can upload an STL file, and have them send it to you after a couple weeks after they manufacture it in their factory. And so it's a great way to get started with 3D printing if you're not interested in making that initial investment in a machine. And these service bureaus often use a lot of more diverse materials. They can print in metal. There are some jewelry designers doing some really interesting things with silver and gold. There's a wide variety of materials that you can access from these services. So what do you print? If you have a 3D printer at home or you want to design something to send away, if you're designing it, or if you're printing at home, there's a bunch of file repositories. The most popular one is called Thingiverse, but there are also models on places like Google SketchUp or GrabCAD, where you can download files that people have created just for 3D printers and print a copy of them for yourself. But after a while, that's not very exciting. Usually people who have a 3D printer want it to use it to solve a problem of their own or make something of their own design. And so that's when you need to learn some sort of CAD software. And there's a ton of CAD software out there. And almost any CAD software on the market, whether it's made for animation or SolidWorks for making assemblies and engineering, all of these programs can export STL files. It's a really common format, and if they can't export an STL file, they can export an OBJ. So you want to pick something you're comfortable with. Maybe it's something you have access to through work, or you can use one of the free programs. There's some really excellent ones that have popped up within the past few years, especially with 3D printing in mind. This is a screenshot of Autodesk 123D Design. Their online version is getting pretty spectacular, and it's one of my favorites to recommend to other folks. Tinkercad is another one that's really great for kids. And I believe Tinkercad just added a Minecraft import function. The two kids in the front row, mouths get really big. How exciting is that? So you can design something in Minecraft and then bring it into Tinkercad and do some more work on it before you 3D print it. All right, so 3D modeling, what's all that about anyway? There's a few ways to do this. You can either start with two-dimensional line work that you are importing, or you can start with basic shapes, primitives like cubes and spheres and cones, all these things you might have learned about in geometry class. And essentially you just add them together and manipulate them in different ways. You can subtract them from one another, combine them to create complex shapes. When you're starting out, a good recommendation is sometimes to copy something from the real world, take some measurements, think about how it goes together, how you would create that object from simple shapes. And it takes some practice, but it's not really that hard, especially if you start with a project where you feel like you can identify the basic shapes that are in that object. And like I said before, there's a lot of free in-browser tools for learning, Tinkercad, 123D being two of the most favorite ones. And it doesn't stop with just the 3D print. There's some folks who are experimenting with some really interesting ways to take these projects further, either doing finishing work on the print itself. That horse head is a scan of a piece in a museum, and it was printed full size on a MakerBot replicator, so it was printed in I think 26 different chunks about this big, and then put all together, and the artist had some access to some metal patinas and did some really interesting work. Doing some faux finishes on that. And then there's also some photos here. There's that lollipop in the lower hand corner of a Tardies, and so somebody had created a design, created a food-safe silicone mold, and then used that to cast the lollipops. And people are doing the same thing, casting with metals, casting with various forms of clay. There's a really interesting in the Met Museum's table inside, somebody had done some negative, it's actually a three-dimensional accordion book by Tom Burtonwood, but how they're using it in there is they're pushing Play-Doh into the voids and making sort of prints of Play-Doh. So there's some interesting ways to try to like incorporate this technology. It doesn't have to end with the plastic print. And you don't have to print in just plastic. We talked about how some of the service bureaus out there already print in lots of other things, in metals, in different grades of plastic. But you want to remember that additive manufacturing means any computer-controlled process that is being built up layer by layer. And so the future is already here. You hear about on the news, people are like, oh, and we just heard, our guy from space talking about the future. If we're going to 3D print cells, we're going to be putting biogels. A little windy here. We're going to be putting biogels through a nozzle and placing them very accurately so we can make cellular structures, or blowing this way up in scale and tying a big giant nozzle that feeds cement from like 3 huge trees and using computer controlling a giant nozzle. And so, all these things you hear about, they're like, oh, we're 3D printing. It really just means that we're building up designs layer by layer with lots of crazy materials. And I'm really interested to see sort of how this technology goes forward into the future. So we've got some learning resources. If you're interested in purchasing a 3D printer in the near future, Make Magazine is going to publish an ultimate guide to 3D printing. It's their 2nd issue, and that comes out in early November. I've got some reviews in there. Read them, they're great. And that's just good advice. If you think you want to jump in, there's lots of different printers out there, and it can be tough to parse out how to get started and what's the right printer for you, and that's what that issue tries to do. There's also some great books on the and the Maker Shed, Getting Started with MakerBot, and some other great books as well. And then this is me. My name is Casey Hultgren. I go by the handle Pretty Small Things online, and you can find me on Twitter and Thingiverse, and send me an email and ask a question. That's all totally cool. And that is it for the standard presentation, and I would love to answer any questions that you have. Yes? How do I change the color of this? Oh, of the print? Okay, so if you're walking through 3D Printer Village and those kinds of printers, the color is actually inherent in the plastic. And so there's a roll of plastic, and it looks a lot like, I don't know, think about it like yarn, like a spool of string, right? It's what would go in a weed whacker. It's actually almost identical to what would go in a weed whacker. It's just a little bit more highly machined. And so the color is actually inherent in the plastic. Now, there are a couple different systems where, in addition to putting down the material, then it's also using an inkjet printer, which is like the printers that print on paper, and then adding color like that, so you can actually print an object that's full color, like a video game character. Yeah. Go ahead. Right, so if you want to have a print that has lots of different colors throughout, the best way to do that is with like a commercial process, and it used to be owned by Z Corp, and I believe it's owned by 3D Systems now. And to do that, you need to go through a service bureau like Shapeways. Although some of the desktop FFF, useful mint fabrication machines, you can print at 2 colors at once, but it's really 2 colors. It's not doing blending for the moment. There's some people doing some crazy experimental work trying to blend colors together, but that's not there in the desktop world yet.
People paint them?
People paint them all the time. Most of the plastics on these desktop machines take acrylics and spray paint, and you can faux finish them. A lot of people, we either sand them down. If you're using ABS, ABS dissolves an acetone, and so I think it's a very scary process, but where you sort of heat up acetone and use it to vapor finish. And the prints look beautiful. It's not something I'm going to try in my studio apartment in Queens, but if you've got a garage, maybe it's worth tackling. The question over here? 3D printing moving parts. Yes, you can do that. It depends a lot on the technology. So the desktop filament machines, you have to really plan out what you're going to do carefully. The main thing that separates the desktop machines that use this technology, we call it FFF, from the high-end machines, which the copyrighted term is, or trademark term is FDM. The FDM high-end machines would start in the $5,000 to $6,000 range and go up to like the $50,000 to $60,000 to $100,000 range. They print in two materials. They print in a dissolvable support material and in the plastic that you're going to be left with. And so you have a lot more options to print in place moving parts because you're going to dunk it in a chemical at the end, and that second material is going to dissolve away, so you can do a complicated gear set. Now, if you want to tackle that sort of work on a desktop printer, it's totally possible, but you have to embrace the machine a little bit more. You've got to keep in mind some of the more complex rules of how those machines work. You've got to get to know, all of these machines are different manufacturing processes. It is rapid prototyping, and you want to feel like, oh, I can just print anything, and you can print anything. But if you want to be on the bleeding edge and push that threshold, you got to get to know the technology. I sort of say it's like you wouldn't try to knit a sweater with a welder right off the bat. You might be able to do that if you're really good with welding, but you got to understand your tool if you want to push it. And with desktop printing, print in place movable parts is sort of an advanced maneuver. If you're on a site like Shapeways or Sculptio or iMaterialize, they'll indicate very clearly what materials you can print movable parts, interlocking parts in. That's the key word to look for, interlocking. And they'll tell you what the tolerance between the parts needs to be so that they don't fuse together in the printing process. Yeah. He's asking, are any of the materials dishwasher safe? I think ABS is dishwasher safe because it's, I don't know an official answer to that. ABS can be pretty watertight and is going to be pretty safe to high temperatures. PLA, which is the other desktop material type, is really only stable to 60 degrees Celsius or 100 degrees Celsius, which means if you left something in your car dashboard, it's not going to be in such good condition when you come back. So that's sort of the limit. As far as the commercial processes go, a lot of them are porous. The nylon is porous. They do have a ceramics one, and I think that is dishwasher safe, but not necessarily oven safe. Yeah. PLA stands for polylactic acid. And you might encounter that material in compostable plastic cups. It's often used. It's that might be PLA, maybe not. If you buy the high-end version of that fork, it might be PLA. Otherwise, it's probably styrene. But PLA, if it is done in a food-safe machine, could be food safe inherently, whereas ABS really isn't. The desktop 3D printers that you can buy are not food safe machines. So once you put the plastic through, it went through some oil and some grease and a dirty nozzle, and maybe you don't want to eat off it anymore, but the plastic itself is food safe. Yeah. Yes. Sure. So how we measure resolution on a 3D printer is by layer height, and that's expressed one of two ways. It's either expressed in millimeters or microns, and so you'll see it dictated both ways. So 0.1 millimeters is equal to 100 microns, and that's sort of important as you're sort of parsing through these different printers and different processes, because we use both. And so on a desktop FFF 3D printer, you're going to be looking at sort of a low resolution of 300 microns. So it's going to be 3 layers in a millimeter, if you can sort of visualize that. down to 100 millimeter or 100 microns, which would be like 10 layers per millimeter. That's about the size of a sheet of paper. It's pretty standard as a high resolution, though there are definitely printers that push that. The Ultimaker that just released their second generation machine advertises 20 microns as their high resolution. Now you got to realize that each of those layers takes like the same amount of time. So if you're going from 300 microns to down to 20, I don't know, I'd have to do the math, but that's like a lot more layers, and it's going to take a lot more time. And the problem with some of these machines is that you don't necessarily, especially on the desktop machines that sometimes are kits, what's hard to quantify is the accuracy. Like, it's very, you can have a 300 micron print that looks better, that you perceive as looking better than a 100 micron print that has like poor registration. So that layer height value is only like one part of the picture, but it's what most people use to describe it. When you're talking about that more high resolution processes like the Form 1 and the B9, I think they're down to like 25 microns. I mean, it's the sub 100 that gets to the point where you really can't see the layers anymore. Yeah. So, I mean, there's two. The resin printers, it's out of a vat. It's sort of a vat, and you're curing it while it's like in the vat of liquid, and that's called SLA. The pro level machines, those ones use something that's a lot more equivalent to a inkjet cartridge, and are laying down the plastic and then curing it with a laser. But that is not technology that has hit the maker scene yet. That's still only available on the high end.
So the ones that are in the maker scene are melting that strand of plastic?
Yes, they're putting it through a nozzle. It is almost literally a precise glue gun.
Is there any off-gas from that?
Yes. There is, and there were some studies that came out earlier this year about off-gassing, and I don't know enough to quote them precisely. So there's two main plastics that people are printing in, and then some other experimental ones. But ABS, which is what Legos are made of, I think they were saying it has sort of the equivalent off-gassing of like cooking on your stove. Because some people were all up in arms after these reports came out, and people were like, oh, it's really not that big a deal. It's sort of like the equivalent of cooking on your stove with some pans. Some people are bothered by the ABS smell, if people are particularly, especially if it's a closed room without good ventilation. If you're working with the PLA, that tends to be a little friendlier. It has more of a sweet, more natural smell when it's printing, and tends to be a little less noxious, and it tends to be the recommendation if you're going to be working in an environment with lots of people, or if you're in a school. Anybody else? Yeah. Can you print in silicone? I don't think I know of anybody printing in silicone. I know of a lot of people who make silicone molds off of 3D printed masters. You know, who will take, and that there was...
If you wanted to make the same mold, you make it out of your PLA.
Right.
Make a silicone mold out of that, and then...
Right. My friend Matt Griffin, who has a book coming out, I believe, in January, called something like Design and Modeling for 3D Printing. It's on the Make. It will be sold through Make. He did some really awesome experiments with some people who are like cake designers and some other food people, and they documented that process all the way through. Although I think you can find it online too. It's something that people have been definitely experimenting with. I think I need to wrap up. I am happy to answer any additional questions off to the side. Otherwise, Dawn Undine from the Met Museum is going to be giving a talk about some of the making initiatives they're doing at the Metropolitan Museum of Art on the live stage, and this is where I'm going to head, and listen to some of the cool things he's talking about. They're doing some really awesome stuff. Yeah, thank you so much for being a great audience. Have a good rest of the day at Maker Faire.